Hey everybody, my name is Greg Sivan. I'm going to be doing VP Problem 7 from section 1.4, number 65. In this problem, we're going to be dealing with Newton's law of cooling, which is given by this equation right here. Alright, where K is a positive constant, we're going to assume that the time of death temperature of the body is 98.6 degrees Fahrenheit, and A is going to be 70 degrees Fahrenheit. First, we have to find the temperature of the body, Tt. So we're going to plug that into Newton's law of cooling equation, and we get dT over dt equals K 70 minus T. Then we're going to use separation of variables. We get dt over 70 minus T equals K dt. Then we're going to integrate both sides. Just follow along down the page, and hopefully everyone can follow along. If not, I got some examples of like what I used and how to get the answer, or how to get what I got, pretty much. But in the end, we're going to get Tt equals 70 plus the constant e to the negative kt, and we're going to call that number 1. All right. Second, we're going to find the value of the constant with the initial condition. So T of 0 is 98.6 degrees Fahrenheit. So plug all that in. We're going to find out that our constant C is 28.6. Now we're going to sub in the 28.6 for C into the original TT equation. And then we get T of T equals 70 plus 28.6 e to the negative kt. You can call that number 2. Alright, third, we're going to find K, where at A is equals 12 noon, when we get the body, or the temperature of the body is at 80 degrees Fahrenheit. So T of A is going to be 80 degrees. So just sub in T of A equals 80 degrees into the T of T equals 70 plus 28.6 e to the negative kt equation. And then do all that work, and then we're going to come up with 10. Now, at A plus 1 is 1 p.m. is the temperature of the body is now 75 degrees. So it's going to be T of A plus 1 equals 75. So we're going to plug that into the equation, and then we're going to get T of A plus 1 equals 70 plus 28.6 e to the negative k times a plus 1. We're going to sub everything in, do all the math, and find what k is. And k is going to be the natural log of 2. Alright, now we have to find the time of death, so t equals a. And as you recall, 28.6 e to the negative ka equals 10. So just remember that, and then do all the work. You get down. T is going to equal 1.516 hours. It's roughly 1 hour 31 minutes. We just subtract the 1 hour 31 minutes from the time we found the body, which, if you recall, was noon. So 12 minus 1 hour and 31 minutes, and we get 10:29 a.m. Alright, hopefully everyone follows and understands.